Hey guys, Anish PyMasters Scholars here. So today we will be having another lesson over stacks where we will be implementing a stack class in Python. So in the last video we implemented a stack as a list, and then we basically just showed the general operations of a stack. Here we're actually going to implement a stack as an object, just like in other programming languages. In other programming languages like Java and C++, there's already an inbuilt stack class already there that uses an array, an internal array as its backbone where all the elements are stored. That's what we're going to be doing similarly today. Today we're going to be creating a stack class that contains these methods right here, which are common of other programming languages like peek, pop, push, empty, size. And that stack class is going to be using a backing list that's actually going to store the elements, and that's where we retrieve the elements from, is from that list, that's going to be stored internally, but externally, how we actually create and manipulate the stack is going to be done through a class and objects. So first we have our peek method right here. The peek method should just return the top of the stack. So we've already learned in the last video that that can just be done by returning the last element in the list. The pop method right here, which returns and removes the top of the stack. We also have the push method, which just appends an element to the end of the stack. That could just be done through using the append method for Python lists. The empty method right here should just be used to return a boolean for whether the stack is empty or not, so whether the length of the list is 0 or not. And then we have the size method, which just returns how many current elements are in the stack, or what is the current length of the list. So now we can create our stack class. So in order to create a class, we could just use the class keyword and then stack. We want our stack class to obviously be named stack with a capital S, and then we want to have a constructor right here, so define double underscore init. That constructor should also have a self reference, and then we're going to create the instance variable for the stack. It will just be a lowercase stack name, and then set that currently equal to an empty list or an empty stack. And then with that empty stack, now we can perform our operations on it. So now that we've created that instance variable for our stack, the first method we could implement is push. So this is where we push elements onto the stack. Push should take in obviously the self reference, but then also a value to append to the stack. So call that value. And then what we do with that push method is we want to add whatever value is specified in the parameter to the stack. So self.stack, our instance variable, append, because lists only have an append method, not a push method. And then we're going to append the value to the end of that list. And then the next thing here is we can have peek. Peek should just take in a self-reference, no other parameter needed. And then peek, so the thing I have to be careful about with peek is that if the stack is empty, in that case, then there's nothing to peek. There's no top of the stack. So we do have to guard against that by checking if the stack, or if the length of the stack is equal to 0, then we have to notify the user that the stack cannot be peeked, that there's no elements in the stack to actually access. So we can say error, just print out a string, error stack is empty. Now otherwise, so else, if the length of the stack is greater than 0, meaning if there's actually elements in the stack, in that case we would just print out the top of the stack, which would just be the last element in the list, because the append method for a list only adds elements to the end of the list, so the last element in the list should represent the element most recently added, so we can just print out, or sorry, we can return the last element in the list, so self.stack at index -1. And then we can have our pop operation right here. We should again just take in self. We have to guard against the stack being empty, just like for peek. So the length of the stack is equal to 0. Just print that same error. otherwise return. So in this case, we can't just return. We also have to remove the element and return. So we just return self.stack.pop. So there's already that inbuilt pop method in Python lists that just removes and returns the last element in the list. So that's exactly what we're going to do. So we're going to return whatever is returned by pop, and that will also remove the last element of the list. There's also size you can define, just taking a self-reference, and we'll just return the length of the list for that, so the length of the stack, or the size of the stack. And then is empty, which we'll just call, we'll just call that method empty. Also taking a self-reference to access that stack instance variable, and we'll just return whether the stack's length is equal to 0 or not, or whether the list length is equal to 0 or not. So the length of the stack or the list, whether that's equal to 0 or not, we're going to return that boolean. So now we've created our stack class. Now let's actually create an object for that stack. So we'll call that object stack. That's equal to a stack. That's going to equal to a reference to a stack object. With that, now we're actually going to push elements onto the stack. So we'll push like 1, or actually we'll loop through a set of numbers for I in range 1 to, we'll go from 1 to 5, so 1 to 6 excluding 6, and then for each of those numbers, we're going to push that onto the stack. So stack.push, that push is going to be that method defined in the class that we can now access through the stack object. We're going to push I. And then so now we can print out, we can print out the top of the stack to see if this works. So stack.pop, maybe the pop method. I'm going to use self right here. There we go. So it's going to when we pop it, it's going to return and remove 5. And then when we pop it again, it's going to remove 4. And then we would just keep doing that. So we could just keep processing the elements one by one. So while the stack's length is greater than 0, or while the stack's size, or while the stack is not empty, so while stack not stack.empty. Empty is that new method that we've defined in the stack class right here. So while the stack isn't empty, we're just going to keep processing all the elements. So print stack pop, and that'll just print the stack from top to bottom, just like that. So it's pretty simple. That's how you implement a stack through classes and objects. We just maintain an internal list as an instance variable, and then each of these operations right here is just going to keep adding or removing elements to that list. We're going to create a stack object, and then we're going to just use that object to call the methods or the new operations that we defined for the stack class. And just like that, and then that's how we would implement a stack class in Python.